Alright, so we are on a Range Rover hybrid. Customer complaint is vehicle's not charging. Apparently there is a high voltage coolant pump fault code logged. So we're just going to go in now, do a scan, and let's see what's going on. We've not confirmed if it is charging or not yet. What I like to do with these hybrid charging faults sometimes is we go in, we get our scan, we save it, have a look what's going on, make a mental note of the codes, try and clear everything down, then process the charging system, because then that way I get the fault codes back that's logged after a failed charge, and I'm not tracing any ghosts, which is always not fun if you start doing that. So I'm going to go in with the top down one, pull a fault report out of it. So we'll come back in a minute. Right, so we've got our global scan now. I'm going to go through and have a look what's going on. So that's fuel pump, not interested in that. Not interested in them. Engine speed, no. Battery charger control module, these are going to be interesting. Vehicle charging electrical inlet internal failure, that is historic. A U3000 control module, component or system operating conditions, so that's going to be related to our charging, I reckon. And in the battery energy control module, our PHEV hybrid electric vehicle battery pack coolant pump is open circuit. So, and then the inverter cooling system performance, that is likely related to the coolant pump. Again, CAN bus faults. So I'm going to confirm that the vehicle doesn't charge. I suspect it's not charging due to the coolant pump fault, if I'm being honest. Especially with it saying all system operating conditions. So that to me suggests because it's not cooling or because it's not got the coolant flow through it, the battery charger module or the onboard charger, as some of you may know it as, is refusing to charge because obviously it can't have the temperature regulation because of the coolant pump. So I think the direction we're going to go down first is we are going to attack the coolant pump circuit, work out why that's not working. It says open circuit stroke no signal, so we could have a bad pump or we could have a wiring issue to it, and we're going to go from there. So the next thing is we're going to have a look at some OEM data for this code, the P0C47, and possibly the P0A93, but I think they're all going to be linked to this P0C47. So we're going to have a look at this code now on the OEM data and take it from there. So just before I start looking at any data, I've just exposed the battery. As you can see here, here's the battery, here's our coolant pipes going in and out. There is a coolant reservoir behind here, we're going to pop that out in a minute as well, just make sure that's got coolant in it. But the signs that we may have had some rodent attacking somewhere potentially with this paper, looks very nibbled and chewed and torn about. There is signs that someone has been in here before as well, because the screws were a little bit rounded and stuff. So we're going to take the side panel off now on that side. We'll have a look at the coolant level. Can't get that off, so we need a trim tool. Just double check the coolant level and then we can attack the wiring for the water pump. Remember right, the fault for the water pump was in the battery energy control module itself, which obviously is this unit here. It's going to be coming out of this plug, so 2 of these wires, maybe 3 of these wires will be related to the coolant pump. We can see a little bit of something on that wire there, don't know whether it's picking up on camera, but there's just a little bit of something on that one there. But yeah, our BECM is going to be internal to this, so we can do some initial wiring checks here hopefully because I suspect the water pump is going to be underneath, to be fair. So let's have a look and see what's going on. Alright, so just pull this panel back. I mean, that battery terminal don't look the best. It doesn't look like it's on all the way, but never mind. Coolant level is okay, it's at the max mark there. It doesn't look like there's any flow returning from it, but there's definitely signs of someone's been in here before, because there is clips everywhere for these trim panels. So I think someone's been chasing this before, or it's had some work done in this back end. I'm trying to fish this clip out, and again, there's a lot of evidence something's been in here, because like, look at all this dust, all this sandy sort of material. But nothing, I mean, that's not even clipped in properly, so nothing's untoward just yet in terms of high armor broken wire. I've been chewed through, but I'm just not liking the evidence here. So let's go get the diagram up and try and work out what's going on. Right, so we've got the circuit information up now, or the fault code information, sorry, for this POC47-31, telling us possible causes is the power ground to the coolant pump itself, an open circuit in the control line, or the pump has failed itself. So it's telling us our circuit reference is on the E-pump out. Refer to the circuit diagrams, check power and grounds, check the PWM control, clear DTCs, run this thing, make sure it sleeps for 10 minutes. The hazard light has gone off, which means the vehicle would then be in sleep mode, and check for the DTC, and if fault persists, install a new coolant pump providing all your wiring checks are okay. So we've pulled the wiring diagram up, so we've got our coolant pump hybrid battery here. We can see that the pump only draws 1.4 amps, so it's quite a smallish pump in all fairness. We've got a couple of interconnectors going on. Battery hybrid, E-pump out, pin 10 on this blue-brown wire, and then we have a power and ground on pins 3 and 1. So we can see this power comes onto sheet 1 at S. So we'll have a look at that, see where that comes from. So we want to find S on this diagram. It comes from here. We have junction box rear, a 15 amp fuse that feeds it, so we need to check that there, because that'll be in this fuse box here. So we're going to start with that, we're going to check that fuse and move on from there. Alright, so I've located the pump, it's here. I mean, it doesn't look the best, in all fairness. It looks like corrosion to the alley body, so I did suspect it to be dead. We're just checking the wiring. So I am in the green, orange and the black. So the black's our earth, the green, orange is our power supply. Now that pump, according to wiring diagram, draws 1.4 amps. So a 2 amp bulb, and it wasn't lighting. So I'm like, right, okay, we've got an issue with the power or ground. I'm now tapped in to just the power to have a look at an open circuit voltage, and we've got absolutely nothing. Now at the fuse we have power, or what I believe to be the fuse. It says fuse 1. In location fuse 1 is a 15 amp fuse that says EV. So I've checked all the other 15 amp fuses and they're live too. So I'm just going to check the ground now, make sure the ground's okay, and then we're going to chase that power feed. But it looks like, yeah, we've got no power to this pump, which is causing our issue. Oh, well, that's interesting. So I've got one lead on battery positive, and now one lead in that earth. Now I should be reading a negative 14 volts, and I am not. I've still got nothing. So we've got both a power and a ground issue to it. There's a couple of interconnectors on this, so we're going to work out where the next interconnector is and just work back in the circuit. I think this has been down before, in all honesty. These white marks on some of the bolts, so I think this rear assembly has been down. But yeah, let's chase that. So at the minute it looks like we've got no power or no ground to that coolant pump. Let's see what we find, shall we? Alright, so it makes a little bit of sense. I don't know how well you're going to pick it up on the camera, but they both go to a C13F connector, which is just here above this heater block assembly. Like I say, I don't know how well you're going to pick it up on the camera, but it's just in this corner here where my finger is now, and there's nothing actually plugged into it. and I think I can see the plug further back just above it. You see it? So I'm going to get that plugged in and see what happens. But yes, I said it looked like this axle had been off before. Plug completely missing. That's the only plug that had the power and the ground in, because further back it's two separate plugs, one for the power, one for the ground. I think the power's on the same as the control line, so that's the only logical one that can have both power and ground on it, and obviously that makes all the sense in the world now. So let's get that plugged in and see what happens. Right, so we've got that connector in now. What a maul that was. But the connector's in. I've tested the operation of the water pump. The water pump is working. I've cleared all codes down and rescanned it now that it's running. We've got 0 DTCs. Everything is normal. So the vehicle is now supposedly happy. All we've got to do now is validate that the plug-in charging now works, which we're going to do next. So let's see if the plug-in charging works, and then hopefully this is a fix, and it's not really a fault with the vehicle as such, you know, nothing's gone wrong, other than bad workmanship, I suppose, because that connector's only unplugged for one reason, that reason being that axle has to have been off for some form of repair. So yeah, bad workmanship, looks like it's caused this. So we'll get this shut now, get this on charge, see if it takes a charge by the Type 2 connector. Let's see what happens. Well, there we go, on the dash, you're seeing charging. So time remains to a full charge 6 hours. We're not going to go that long. Probably give it 20 minutes, half hour or so, make sure it doesn't kick itself off. But we can hear the cooling fan going, so it's regulating charge temperature. If we look on the charger, this isn't going to charge. Oh, there we go, it's just kicked in, sorry. It must have been balancing. So we look on the charger, something interesting's happening. It's charging, not charging. So we'll just drop back out. If I give this a second. So flashing green light is that fast, is that slow? See, it's coming in, charging, not charging. Charging again now, and it's just stopped. So is that slow, fast? Slow, fast, or fast flash? I think it's fast, which indicates a CP line issue according to the charger. Let's see what happens, because it is coming in and out of charge, so it could be balancing the battery in all fairness. So we'll give it half hour and see what happens. Right, so it's not taking a charge. Just going through a bit of live data, and in the battery itself we've got rebalance cannot be started, we have a battery fault. We've got a 3% variation in state of charge, you know, 20, oh hang on, we've just gone into initialising, now we're running. Hopefully, because we've got it running and trying to charge the battery externally, it might recover. Let's see what happens. But like I say, yeah, we've got a variation in the state of charge between the cells, 20 millivolt variance between the battery modules, which isn't a lot, but I have seen less cause issues on other vehicles. So I'm going to try and get some charge into this via the motor acting as a generator with the engine running. Try and get this rebalance complete, and once the battery's rebalanced, doing its own thing, hopefully it'll take charge externally. So we've gone to rebalance completed successfully now. So I'm just going to check all the fault codes, and then we'll test it from the external charging source.